Hello, my name is Shima Dalirova. I'm a research and development scientist at In Vitro Diagnostic Solutions. I present our work today on behalf of the R&D team at IVDS. Before getting to the detail that how we have designed and developed a universal rapid point-of-care diagnostic test for the detection of rare metabolic disorders, I will give a quick background about IVDS. Then a brief explanation about Prequine platform and how we have designed and developed that platform for the detection of G6PD and PKU as two rare metabolic disorders. IVDS founded in 2017. Here are the team members working on G6PD and PKU projects. Prequine platform is a quantitative, robust, user-friendly, and cost-effective point-of-care diagnostic device, which includes disposable finger-stick blood draw kit, handheld meter, and a mobile application. Prequine is a universal platform with a direct connectivity to a cell phone by Bluetooth to receive data from meter. Each lot of test strip has its own QR code, which can provide lot number, calibration, and expiration date. The core technology of the meter is based on using 3 LEDs to calculate person reflectance, which is driven from the specific level of target biomarker activity. IVDS granted over $3 million fund from National Institute of Health for developing point-of-care diagnostic device for the detection of G6PD and PKU. Now getting more into the detail, what is G6PD and what does G6PD deficiency cause in body? G6PD is an enzyme, and as shown here, its deficiency leads to the increased amount of the hydrogen peroxidase in a body. The elevated level of hydrogen peroxidase leads to the cell damage and hemolysis. What is the main reason for developing a point-of-care device for the detection of G6PD deficiency? G6PD deficiency is one of the most frequent inherited blood disorders. As I explained in previous slides, its deficiency leads to the hemolysis of red blood cells. Around 400 million people affected worldwide, including in malaria endemic region. Malaria caused by a parasite transmitted to humans through mosquito bites. It affects over 200 million people with 440,000 deaths annually. Pyrimaquine or tafenoquine are the medications using for acute attack of malaria. These two medications may induce oxidative stress. Therefore, using them for patients with G6PD deficiency leads to acute hemolytic anemia. So physicians need to know the G6PD normal activity before prescribing them. Therefore, having access to a rapid diagnostic is necessary for this group. Current G6PD detection approaches can be categorized into two groups: quantitative measurement, which express as units of G6PD activity per gram of hemoglobin. This approach available through Point Scientific or Trinity Biotech, and it requires around 1 milliliter of blood. Blood also requires manual lysis. Then the hemolyzed blood will be analyzed by UVVs. This approach also needs a separate instrument for hemoglobin measurements to calculate the G6PD activity as units per gram of hemoglobin. Total turnaround time to run the assay is around 30 minutes. The other approach, Binax now, is a qualitative test, which requires around 10 to 20 microliter of blood. Since it's qualitative, it doesn't measure the hemoglobin. It takes around 10 minutes for the analyzer to read and give a report. Therefore, there is an unmet need for a fast quantitative G6PD detection device, which requires low blood volume. Prequine platform is a colorimetric point-of-care device which can provide simultaneous measurement of G6PD and hemoglobin with a 5 microliter blood sample, which can be taken by a finger stick. It has a wide detection range for both G6PD and hemoglobin in a 6-minute test time. G6PD test strips, as it's shown here, consists of 4 membranes. Transport membrane provides a uniform distribution of the blood. The blood flows transversely across the membrane, then migrates vertically. It contains hemolytic agents to provide hemolyzed sample. Optical membrane removes small particulate cellular debris and provides a uniform color across the surface of the hemoglobin detection pad and reagent membrane. G6PD reagent membrane contains immobilized indicators and provide color change from yellow to blue. The higher the concentration of G6PD, A darker blue color shows up in the detection zone. As mentioned before, Prequine is a colorimetric platform. The color change of the G6PD detection pad from yellow to blue is based on the color change of the immobilized tetrazolium salt on the reagent membrane. The higher the concentration of G6PD in a sample leads to more oxidation of the indicator and leading to a color change to a blue formation. IVDS investigated various indicators to find the best with higher sensitivity and specificity. As shown here in the full spectrum graph, the selected indicator doesn't have any interference at 670 nanometer with hemoglobin and bilirubin. Here are the results from the Prequine platform. The graph on the left side shows the Prequine dose response at different G6PD concentrations in a 6-minute assay time. By increasing the concentration of G6PD in sample, the color of the reading zone gets darker, so the percent reflectance decreases. The higher the delta we have between the high and low end concentration provides higher resolution. We have also performed hemoglobin interference study to make sure by changing the hemoglobin level in samples, the percent reflectance for G6PD doesn't change. As shown in this bar graph, by increasing the hemoglobin level, just the percent reflectance for the hemoglobin decreases and no change observed for G6PD percent reflectance. Now I'm going through the other project we are working on at IVDS, which helps the patients with PKU disease. Phenylketonuria, known as PKU, is a rare metabolic disease, leads to severe brain disorder. PKU caused by the accumulation of an amino acid called Phe to a toxic level in blood. By increasing the level of Phe, neurotransmitter biomarkers such as norepinephrine, dopamine, and serotonin begins to fall, leading to severe intellectual disability, psychiatric disorder, and seizures. Therefore, it's necessary for these patients to have access to a home Phe monitoring device to have a better control on their diet. Currently, there are no available home Phe monitoring in the market. Phe is a small molecule, less than 900 Daltons. Therefore, it's hard to detect. The current detection technologies can be divided into two groups. In a direct method, the blood sample sends out to the central labs to measure quantitative amount of the Phe levels by HPLC or mass spec. Other approaches, such as enzymatic or fluorescent-based assay, are indirect detection of Phe. Taking advantage of Phe chemistry, IVDS developed a Prequine platform based on enzymatic reaction. The higher the concentration of Phe in blood samples leads to higher reduction of tetrazolium salt to form a blue formazan product. Phe detection test strip consists of 3 membranes. Primary and secondary blood separation membrane placed on top of the Phe reagent pad. Phe level between 2 to 6 mg per deciliter considered as a healthy physiological range. With Prequine platform, we could successfully detect Phe in a wide range of 1 to 25 mg per deciliter in a spike blood sample in 3 minutes assay time. We have also investigated the tyrosine and hemoglobin interference in Prequine platform. The reason for studying the tyrosine interference is the almost similar molecular structure of Phe and tyrosine. The tyrosine spiked at 3 mg per deciliter, which is the highest concentration in normal Phe range. As we see in the bar graph on the left side, the percent reflectance for samples contains Phe versus Phe plus tyrosine is the same, and the percent reflectance decreased based on the Phe concentration. For investigating the hemoglobin interference, 2 levels of hemoglobin tested with high and low Phe concentrations. The bar graph on the right side shows that there is no hemoglobin bias for the Phe detection based on percent reflectance in Prequine platform. Here is a projected timeline for G6PD and PKU project. G6PD started a year before PKU, so PKU is estimated to be in the market in 2024. In summary, Prequine platform is a user-friendly and low-cost point-of-care device, which provides quantitative test result for the detection of G6PD and Phe in a drop of blood sample. It provides accurate and precise results like central lab analysis. It also has the ability to store the data and sends the result to the clinicians. IVDS would like to thank the funding agencies and collaborators for their supports. At the end, I would like to thank you all for your time and watching this presentation.